Okay, Assalamualaikum. We meet again in the second part of chapter 3. Okay, basic principle of FM. Basic principle of FM. First is frequency deviation. Second is modulation index. Three is Bessel function. And four is power analysis. So let's see one by one. First is frequency deviation. So when we are talking about frequency modulation, basically we are discussing about frequency deviation, delta F. So what is the definition? Relative frequency deviation is defined as relative displacement of the carrier frequency compared to the original carrier frequency. The unit of frequency is always in Hz. Hs. Okay. So let's see this figure. You have this. What is this? This is the sine wave. Okay. So we have the this is the sine wave of information signal. Okay. Sine wave of baseband signal. VM. The information. Okay. So this sine wave have amplitude, right? The amplitude, this is the peak, positive peak, and this is the peak, and this is the valley, or this is the positive peak, this is the negative peak. So basically from the peak to the valley, it represent frequency deviation, either plus delta F or minus delta F. Here this is FC. So from the original carrier frequency FC, so the frequency will be changed either plus, which is FC plus delta F, which is we call it positive deviation, or FC minus delta F, which is called negative deviation. Okay, so negative for this is for the valley, the frequency is FC minus delta F, and for the peak, the valley or the negative amplitude, FC minus delta F. For the peak, which is positive amplitude, the frequency is FC plus delta F. So, okay. So basically, you can expect the higher the amplitude of information signal or the baseband signal, VM, the bigger the deviation, the frequency deviation. Okay. So the lower or the lower the valley, the bigger the negative deviation. Okay. Frequency deviation, delta F. Delta FM is the process of changing carrier frequency by the modulating signal while the carrier amplitude remains constant. The amplitude of the carrier remains constant, but the frequency of the carrier is changing according to amplitude of the modulating signal. As the modulating signal amplitude increase, as the amplitude of modulating signal increase, the carrier frequency increases, or the frequency deviation increase. The amount of change in carrier frequency produced by the modulating signal is measured in peak frequency deviation. Okay, frequency deviation. Sometimes frequency deviation can also be expressed as maximum carrier swing, which is equal to 2 delta F. 2 delta F. Okay, this is called carrier swing. Swing means from the maximum positive to maximum negative, or from the maximum to the minimum. The deviation is proportional to the amplitude of the modulating signal. Okay, the deviation is delta F is proportional to the amplitude of modulating signal. Okay, yeah. So this is delta F, dual delta F. This is called uh, carrier swing. Yeah. So carrier swing is the swing of the frequency carrier from this is the minimum to the maximum, which is equal to delta F, dual delta F. Okay, carrier swing in terms of frequency, yeah, equal to dual delta F. Dual meaning from here, one here, and another one here. So 2 delta F. Okay, frequency deviation delta F equal to frequency deviation can be calculated using this equation. Delta F equal to Kf Vm, which is Kf represented by deviation sensitivity. Kf is deviation sensitivity. Vm is the peak of modulating signal. So how to calculate frequency deviation? Kf, what is Kf? Kf is the sensitivity of deviation multiplied by Vm, which is the peak of modulating signal. So we can see that delta F, frequency deviation, is directly proportional to the modulating signal amplitude. This is the amplitude Vm. Okay, delta F directly proportional to amplitude of modulating signal. What is deviation sensitivity? Deviation sensitivity is a constant that shows the sensitivity of frequency modulator. Represent the input-output transfer of the modulator, the relationship between input voltage and the resulting frequency shift. So Kf is equal to omega W over this is delta omega over delta Vm. Okay, or in Hertz, delta F in Hertz over volt. In short, it shows how well the modulator works. Okay. Next parameter is modulation index. For Fm, we call it frequency modulation index, M, also represented by M, modulation index, similar to the amplitude modulation signal. The ratio of frequency deviation to the modulating frequency is known as modulation index, M. And this M is, because of the ratio, it is no unitless. So M is unitless. M is ratio of the frequency deviation delta F to the modulating frequency. Okay, M equal to Kf Vm over omega M, or Kf can also be expressed in Hertz. So M is Kf Hertz over volt, Vm over Fm. So this is radian per volt, this is Hertz per volt, unitless. Since delta F equal to Kf Vm. Therefore, M equal to delta F over Fm. Okay, so for frequency modulation, the modulation index equation is equal to delta F over Fm. So you need to remember this. Modulation index is frequency deviation over modulating frequency Fm. Okay, so this is the modulation index. Okay, modulation index. Similar, in most communication system using FM, maximum limits are put on both the frequency deviation and modulation index. So FC plus FM, this is the frequency, and this is FC plus 2FM, FC plus NFM. This is the side. Budak lah pula. Okay, so we will discuss later about this example. You need to try first. Thank you very much. That's all. Thank you very much. Dia kacau lah pula. Bye. We will discuss about the example lah. Okay, tak ada dah tu. Okay, modulation index. Ini ingat lagi ya, delta F over Fm, modulation index for Fm. From this, we can calculate the percent modulation. Percent modulation is calculated by using this equation, delta F over delta F max multiplied by 100. So it become percent modulation. In most communication system using FM, maximum limits are put on both frequency deviation, this one, and modulating frequency, this one. Okay, so this equation represent the sideband of the FM signal. We will discuss later about this. FC plus FM, the first sideband. FC plus 2FM, the second sideband. FC plus NFN is the N sideband. Example, using the previous discussed equation, determine the modulation index or FM signal with modulating frequency. Modulating frequency itu apa? FM, right? So FM 10 kHz. Deviation 10 kHz plus minus. Delta F 10 kHz. The total frequency change, okay, answer is M equal to delta F over Fm. So, sama je, delta F is 10 kHz, Fm is 10 kHz. So motion index is 1.0. Boleh ya? The motion index is unitless. The total frequency change, or we call it the carrier swing, carrier swing 2 delta F equal to 2 10 kHz equal to 20 kHz. Senang kan? Okay. Next example. A cell phone transmitter has maximum frequency deviation of 12 kHz. Calculate the modulation index if it operates at maximum deviation with voice frequency of 300 Hz. So apa ni? A is given delta F equal to 12 kilohertz. So F equal to 300 Hz. So therefore modulation index. This will ke apa ni? Calculate the modulation index. Okay. M. Modulation index M equal to delta F bahagi dengan FM sama dengan 12 kilohertz, 12,000 Hz bahagi dengan 300. 120 bagi 3 equal to 40. Unitless unitless. So answer 40. B 12 sama je lah ni. 12 delta F bukan A delta F equal to 12 kilohertz. FM equal to 2.5 kilohertz. So M equal to delta F bagi FM 12K bagi dengan 2.5. Okay. So ini 12 bagi dengan 2.5 answer is baiklah. Berapa calculator? 4.8. Betul lah. This is M modulation index. Okay. Okay, so that's all for this part. We will discuss about sideband to this sideband. Remember sidebands? Okay, we will discuss later in next video. Okay, so that's all. Thank you very much. Bye bye.